Bill, I think we can get started. What do you think?
I think we can. All right.
Well, cool. Well, hello, everybody. My name is Eric Urrutia. I'm with North Park Innovations Group. I've been around the industry for quite a while, about just a bit over 25 years now, and I've worked in every aspect of it, from being a technician to wholesale and now part of manufacturing. Over the years, I've got over 10 OEM certifications underneath my belt. A lot of work. Now, just to catch up on everything, we did have a webinar last Thursday, on getting started with the iManifold, pairing up the probes right out of the box, going from there. Excuse me. For any more information, please visit our website. If you missed it, it's available. Visit our website, www.imanifold.com. Check into news. That way you can keep up on any of our other future webinars, any virtual trainings, what have you. Now, for questions, if you have questions right now, I see most of you have started using the chat. Just type in your chat. We're going to try and get to as many questions as we can. If we don't get to your question, kind of pass them over to Tech Talk. That's on our website as well. You can post your questions there. We'll get to them all as soon as we can. So we've got Bill Northrup on the line with us today. He's going to be helping out, answering questions. There's Bill.
Hey, everybody. So I'll be reading the questions and pitching them to Eric as he goes along. So hopefully we'll have a nice evolution and we'll all learn something.
Thanks, Bill. All right. First, what we're going to start off on, you see my application is open right now. I've got my iConnect gauged up to a system. Like I said, it's a little demo system. It is a 410A unit, but we're going to go into profiling in just a second. What we want to do first is get in and configure our system. So you see my little smiley face over here. This is what I'm going to consider our gear menu. On the other side over here is our bar menu in the upper left-hand corner. So over here, going into our gear menu, we open it up. This is going to give us all the information here. It shows that we're connected. That's our battery life of our iConnect unit. This is if we want to disconnect. Our sampling rates, high, medium, and low. Medium being the choice. The configuration of the hardware. Your wireless probes, Tech Connect, account, tools, all the way down here. We're not going to get all into those. Those are going to be on future modules. Right now, what we're going to look at is configuration. We open configuration. Right up here on the top, on our iManifold settings, we have the name of our iConnect. You can actually edit that and change it to whatever you want to put on there, your company name and the user of it. You've got auto shutdown of 5 minutes. That's the way they come from the factory as a default. And your battery type is standard. Now, you can use rechargeable batteries. If you do use rechargeable batteries, edit that, put in rechargeable, because they do discharge at a different rate. Now, the auto shutdown here, after 5 minutes of inactivity, the iConnect will shut itself down. So waiting for a system to settle up and everything, you may want to extend that timeout. So we're going to go ahead and edit this. Go to our auto shutdown here. We're going to open it up. And I suggest either 30 or 60 minutes, depending. After these selections have been made, you can change the name. Like I said, change it to 30 minutes, go to rechargeable batteries. Now we submit. We've discussed this in our previous trainings. The word submit, any submit button, that is your best friend. When you put in information, you want to make sure that you hit that submit button. So now that we have everything set in as far as our settings go, we take a look at our iManifold information. There's the name of it, there's our serial number of the unit. Now, none of this you can change. This is showing our firmware. Firmware updates, when they are available, it will show up in a bubble in the center of your screen, and it'll say firmware update is available. Take a look at it. If you're in a position where you can update, go ahead and push update. It'll take it right off the application, and you'll be all up to date. Right now, we are on 1.2.0. So from here on, we can go back into our iManifold and get started. We're gauged up on this system. Right now we have no profile. Profile of a system is basically the refrigerant, the metering device, the efficiency, the configuration of the system, whether it's an air conditioner, straight cool, a heat pump, or low temp refrigeration. So to profile, we're going to go up here to the 3-bar menu, open that up, and we see our tab here, equipment profiling. We open up that tab. Now there are some units that are already profiled in here. You'll see several of them in here. You can always eliminate as many as you want. You can make new profiles. What we'll do is we will actually make a new profile right now. We're going to go up here to Profile New System, open up the tab, and here's all of our parameters: our refrigerant, system type, indoor metering device, condenser type. Once you select your condenser type, there will also be an evaporator type as well. Our target superheat and subcooling. Nominal tonnage. Putting in nominal tonnage on here is really not necessary because it's not going to be saved anyway. We can create a quick profile and name some ourselves, which is what we're going to do right now. Refrigerant. We have a 410A system, but we have a choice of just about every active refrigerant around there right now. A couple of new ones in here. There's the new Honeywell refrigerants out here that are drop-ins for 22. Those are going in here. So right now we're going to select 410A. The system that we're currently hooked up to is a small AC unit, so we will select AC. Our metering device is a fixed orifice. Now we're going to select our condenser type. We'll go 10 to 12 SEER, mid efficiency. Our evaporator type. Now head pressure controls, you're going to see that on low temp situations. That is if you're profiling a walk-in freezer, display cases, beverage coolers, things like that, you're going to have head pressure controls. Right here, we're going to select on our evaporator type, we're going to go standard operation. Now, that's going to be 90% of it. If you do have an area where you're using a high SEER condensing unit, that's say a 3.5 ton, a lot of times they'll team that up with a 5-ton evaporator. In that case, you want to select high sensible capacity. So now here we're going to select a quick profile. We're going to make one up. And like I said, here's our submit. That's our best friend, submit. This is just verifying that we want to make a quick profile. We select yes. Now we can name this quick profile, or we can use auto name. You can enter whatever you want in here. You can name it, Bill's house, whatever you want to do. I like to use just an auto name because it'll pull up the information. That way I can identify when I look at it again.
Hey, Eric.
Yes, sir.
We got a question from David Small. He said, what is DCTOA? Couldn't find reference. Is it ODU temperature rise?
That is design temperature differential.
Okay. Thank you.
On the other side, also just on that point about abbreviations, if we go over to our gear menu over here, we'll just jump over here real quick so you can take a look. And on our help, you can see on help videos and tutorials, on the very first one with general information, it will show you the abbreviations. Okay. So back to our profiling. We've selected air conditioning with 410A. We have a fixed orifice. We are going to use a 10 to 12 SEER condensing unit. We use standard operation on the evaporator. This is to be determined, and we've actually already submitted this in. So this profile is present and it is applied to what we have here. Now, as you can see, on our active temperatures, being gauged up, we are showing our suction line temp, our liquid line temp. I'm not pulling discharge line temperature because this unit is really tiny and I can't even get anything in there to do so. And we've got our outdoor air temperature. Now, with all these measurements, with the profile that we just selected up, we can actually determine what our targets are here. Our low side pressure target, our high side pressure target. Go back over here to our target screen right quick. There we are. As you can see, our target suction pressure is 115. We're running at 113. Really nice. Our target superheat on here is 5. Now that is something to be calculated. This little system that I'm running out here, it's rather difficult because it's not per se a system that's it has no ductwork, things like that. So as far as our target superheat, as to what I'm producing right here at 25 degrees of superheat, it looks like it's pretty far off, but in all actuality, it's running a 20-degree split. Pretty nice. We've got a 360 target head pressure. We're spot on that. Here's our saturation temperatures. Sorry about that. Saturation temperatures, 37.8 on the VAP side and 108.7 on the condenser side. Across the bottom here, our targets. We can go to our air side measurements. We have our return air dry bulb, return air wet bulb, supplier dry bulb, and supplier wet bulb. Wire temperatures on a iConnect. If you look at my picture screen here, this is the iConnect that I'm using right this second. Nothing gets plugged into the back here. If you have an iManifold, different story, because all your temperature probes get plugged into the back. These get plugged into the probes themselves. So nothing, do not plug anything in to an iConnect on the back of it. It will give you some crazy measurements. So now after we've entered in the profile of the system, we can scroll through our probes, all of our probe information. Probe number 3 is supplier dry bulb with relative humidity. Probe number 2 is head pressure, liquid line temperature, and subcooling. Probe number 1, low pressure, suction line temperature, outdoor air, and superheat. Here's our performance page. We're not showing any tonnage or BTUs or EDR. That's because we have not put in a value for tonnage as of yet. To put in your value of tonnage, so you don't have all these profiles here, because if you had quick profile and this same thing with a 13-seer straight cool, 410A with a TXV, if you had one that was a 2-ton, a 2.5, a 3-ton, if you put all the tonnage in there and saved it, over here on the side, you'd have a mile-long list of quick profiles. So we just want that basic information, and we can put the tonnage in on this same page over here. Now, putting in tonnage, we go here to measurements. We open up our measurements page. And as you can see, we've got pressures, temperatures, air across the evaporator, airflow nominal tonnage, static pressure, and electrical. Now, we can peek at each one of these. As you can see, if you open up your pressures tab, you've got live pressures going. Tap it again to shrink it down. Temperatures here. We've got our suction line, liquid line. We're not taking discharge line temperature right now. I could put it in manually, but we won't do that. Air across the evaporator. As you can see, we've got a return air dry bulb, return air relative humidity, supplier dry bulb, and supplier relative humidity. Now, right here, we've got this nice little button here to go from relative humidity over to wet bulb. We just slide that over. We got wet bulb temperatures now here. Let's shrink that back down. Now we've got airflow and nominal tonnage. We open this up. Our airflow method that we're using is estimated auto calculate. That is an algorithm that is using all the measurements that we've got going and utilizing our supply and return air probes. You just need to put in a parameter for it to look at, which is the nominal tonnage. This little system that's out here is a half ton, so we're going to put a 0.5. And like I said, submit is your best friend here. That little smiley guy, that's his best buddy right there. Hit submit. And now, as you can see on performance, we're displaying our tonnage, we're displaying our BTUs and our split. Now over here on the bar menu over here, I'll go back over here to the bar. While you're looking at all this information is coming into you. You've got your bottom menu across, give you all your temperatures, your targets, air side, active temperatures, every piece of information that you need. Now, you can look at performance while the system is running. Simply bar menu, open up, and right down here towards the bottom, we've got system performance. We open up system performance, and we've got everything here. Airflow and total external static pressure, measured capacity and BTUs, all your additional measurements with sensible heat ratio, enthalpy in and out, dew points, your system references, the barometric pressure and elevation. And we also have our evaporator performance with our temperature split. Now it'll give you a target temp split according to conditions. And so right here at 400 CFM per ton, it's estimating a temp split of 22.5. Our actual temp split right now is 19.8. So it'll give us a deviation from target. We're 2.7 degrees off target. Here's our dehumidification. As you can see, we're dry. This is horribly dry. As you can see over here on our capacity over here, our latent BTUs, there is none. No latent BTUs. It's just bone dry. So we go back into our manifold here. Let me take a quick breather. Is there any questions out here, Bill, that
yeah. Well, you know, now's a good time. Jason was at John Stone in Chicago today.
I saw that.
He was doing a nice demonstration, and it was pretty cool. Lori, can you put a photo up of that? Maybe she can. We'll see. Anyway, you know, I think, one thing I wanted to mention, we got a guy by the name of Bill. He's in Hawaii. So thanks for taking the time and coming in. Hopefully you're using an iManifold there, iConnect. So, all right, Eric. Yeah.
Oh, I got technical difficulties.
Uh-oh, do you? Oh, yeah. All right.
Come on now.
You know, we had a pretty good challenge trying to figure out how to take from an iPad and or an Android and put it on the screen and go through our web presentation to really show. Up to now, it's worked pretty good. Hopefully, everybody's gotten a good help and a good feel for what it can do.
Now, are you still getting my camera and my screen?
I'm getting you. We're getting you, but we don't see the your screen. Well, we see the screen. It's not moving. It's not live.
The iManifold screen?
Right. Right.
I don't know what just happened, guys.
Did she lay down? Is yours alive right on your end, or is it the connectivity between the device and the internet?
It's just showing that my Zoom is not responding. So do you see my smiley face, guys? He's still moving around.
No. No.
Oh, no.
Well, I guess
the network hang up. I hope can everybody still hear me?
Well,
Yes, we can hear you all right. And maybe you want Nick to tell us a little bit about these iManifolds from the production point of view.
yeah, that's a good idea.
Nick, take over. I'm going to try and resolve my fix here.
All right.
All right, let me see if I can get this opened up.
Yeah, and Eric, Norm says, try logging in, logging out, and logging back in again.
I may just do that. So if I jump off here for a second, I'll be right back.
You got it. So, Nick, you're gonna show? There you go.
Yeah, I'm trying to pop up this video. I wasn't really too prepared.
No, I know it. We should have been thinking about that.
So yeah, I still see Eric's display up on the main screen. I'm not sure if that's populating the screen for everybody, but we can just go through a little bit more about the probes and the iConnect. I'm not too sure how familiar everybody is with all of the product line. I don't have any air probes sitting right in front of me, but so on our pressure probes, these do come with the T's and the 6-inch hoses. So if you've got to add or recover any refrigerant, you'll do right through the T right here. And we do have our dual port manometer and a repeater. I have moved all of my temperature straps to go through what we have for that. Nice.
I am ready.
Back up and going.
Cool.
Okay, here we go. Let me get back on here to get my screen back up. And we're back in business.
And while you're going there, we have a question, Eric, the purpose of the repeater.
Repeater, there's a lot of confusion with the repeater because a lot of guys, they'll think that that it helps out their Bluetooth. Okay, Bluetooth has nothing to do with our repeaters. The repeaters are solely for putting another radio into our Zigbee network. The more radios you have in the network, the stronger your network is. But as far as the repeatability with Bluetooth, I mean, that just doesn't exist. And that's where we go into play with the iConnect, because this little unit is actually worn on your body, and you're taking advantage of the Zigbee radio network to get all the range. So where you've got a very limited range with Bluetooth, you've got a whole lot more range with the Zigbee network. Placing a repeater, if you've got an extremely large residence or business, 2-story, 3-story building, you've got probes up on the roof, you've got long range, you got your repeaters and everything else. A repeater put up on the edge or in a windowsill for that radio signal to come out and exit. That's what the repeaters are all about. It's for your radio signal, not the Bluetooth. So you can put 20 repeaters into a system, and it's not going to help your Bluetooth out at all. So back in here, where we're at about putting in nominal tonnage on our measurements, we select our measurements, put in our nominal tonnage, and go to submit. Like I said, our buddy is that submit button. Now we can scroll across the bottom here, take a look at all of our pressures and our performances back again. Now we do have an ER here. to put in ER, to get an ER measurement, we need to put in electrical information. So let's go in here to our 3-bar menu. Go down here to measurements, open up measurements. We'll just shrink down the airflow nominal tonnage. We'll go over here and open up electrical. Now, as you can see, we have this connect to multimeter right here. We do have a multimeter that we do not manufacture. There's one out there, it's the Redfish meter, that will connect to us Bluetooth. There's no pairing up of the probes or anything like that. It's strictly Bluetooth to your smart device. So you do have limited range on that. But it will input your electrical measurements, your voltage and your amperage wirelessly. And when you do a report, it shows up as a verified measurement. So that's kind of handy to have. We'll have another little bit on that shortly. Not on this train session, but next time around. So in our electrical information, we take a look at the configuration of the system. This little system that I have out here is a small little package unit. So we'll slip this over here to package. It is a single phase, but it is 115 volt. So we'll slide this over to 120 volt. And we've got our voltage and our amperage. Now I checked it out before. We were just at 121.7 volts. And going in here to our amperage, we were at 3.92 volt. Tap on our amperage, and we're at 3.92. And like we said, that little thing right there, they belong together. They're pals. Submit. Now when we go back in and we take a look, we've got our tonnage there. We have our BTUs. Whoops. We have our BTUs. We've got our split, and now we have an EER rating. Very simple. All this information can be done just with those few simple probes. Put in our high and low pressure, our suction line temperature, our liquid line temperature, our supply and returns, placed properly. All this information, something that you never get out of anything else, and that quickly.
Hey, Eric, Bill from Hawaii had a good question. Are we going to end up putting as many profiles as possible such that you can automatically download those profiles and then you don't end up putting in wrong inputs, you know, and then not getting good data?
You mean for us to input more of these profiles?
Right, right. So what he's saying, and for sure that's what we're going to do, Bill, is, you know, there's a lot of data input into these right now when you set up a profile. And if we actually can have the good profiles of the new equipment such, and actually we're going to talk about that later with the AHRI database, I'm sure, but there's a whole lot of equipment that would be nice to have profiles for.
Definitely, definitely. But we could actually input more of these profiles because in all actuality, a technician that's, say he's an HVAC technician, he's not going to run into a whole lot of different profiles.
Yep.
Now some of the older stuff, the 10 SEER stuff is going away. You're going to be up to 12, 14, 16 SEER. The configuration between being a straight cooler heat pump, whether it's going to be a fixed orifice or a TXV. You know, so in all actuality, when you take a look over here on your profiles, you might have 8 or 9 up here. That's it.
Yeah.
That's all you would have on there, because with this, we could select any of these. We can make all these new profiles, because this is actually a little profile for this unit that we're working on right now. So I could select that, and we're right back in business here.
And Bill, maybe I didn't do justice to your question for Eric. So perhaps you could go to Tech Talk and begin a thread. We really want to start using that to get good information from the whole user group so that we're heading in the right direction with new product development, new reporting, things like that.
Yeah, definitely. You know, follow your questions over to Tech Talk. We can get to them as soon as possible. I'll be, after this this training right now. I'm going to be on it, and I'm going to try and answer all these questions that I can. And then the ones that we need to discuss, we can discuss that. Just like Bill's question why about putting in more of the profiles. I mean, I can think of probably 5 or 6 more profiles that can be put in, and it applies to just about anybody. So we can look at that, definitely.
Yeah, yeah. Another Bill Hansen liked to see. He said he has a redfish meter, and he'd like a class on that as it becomes available, and that's good input. We'll do that.
Definitely, that redfish meter. It's a nice little meter, but it has to be followed step by step without any deviations, so that your measurements do come in and they stay in there.
Yeah.
Nice little meter.
Yeah.
But we can definitely put a little training seminar together for that as well.
Yeah.
What else do we got, Bill?
Well, Norm wanted us to point out the difference between the long range and short range probes. Of course, we started delivering them in October, I think, of last year, the long range. Maybe you can tell folks what's the deal with all that.
Well, have no fear. Your first generation stuff is still supported. It's all backward compatible. So if you have the first generation stuff, for the most part, those things worked out just fine. It's just a lot of these people are working on larger buildings, larger homes. Out here in Phoenix, everybody's flown over Phoenix. They say, well, every building looks the same because they're all tan, brown, and they're all made out of stucco. Well, stucco, as we know, is just it's chicken wire with cement over it, and then it's painted, basically. Stucco, the chicken wire in there acts as a big antenna, and it's a signal sucking machine. And it's just horrible.
I bet.
You can get out on a job and your signal just gets eaten alive. Now, when we got approved for the long range probes, that really helped out, because where you're not going to need the repeaters anymore. You've got long range, but if you do have old stuff, I wouldn't say old stuff, but the first gen, you can use 2 repeaters that are long range in your system. But the thing is that you have to have one inside and one outside so that the communication can go in to out to in.
So remember, these are transceivers. So each probe has a receiver and a transmitter. And when we went to the long range, then you can make a bridge with 2 of those probes, and that's your bridge. And it works very well that way. We've found it. Remember,
so even the first generation probes, they will communicate with the new long range probes. Same signal and everything, just one's a lot stronger.
Yeah.
So putting 2 long range probes into your first gen standard range system, you'll get long range effects out of that.
And one final thing on the network, on the mesh network of the probes, think of that. They use one another to get the signal back to your iConnect. And so the more you have in the network, the more powerful the network is.
Absolutely. It's just like in the town that you live in. You've got your cell phone. All the towers that are around all over the place. All those are it's a repeater. Exactly what it is. So the more repeaters, the more probes you have in the system, in your network, it's a whole lot stronger. And you can put up to 12. You can put 12 radios into the system, and any of the probes can act as a repeater. If you don't map it for anything, it might just be pulling a temperature. It's pulling a relative humidity, whatever it may be pulling. Or if you're just using a repeater with temperature and no temperature's plugged in, it's simply using to bounce off another radio signal. So.
And then we have found that the long range radios, we're getting, line of sight, they'll go 1,400 feet from the iConnect to the probe. Really in real time, probably through a few walls, figure 1,000 feet. With the older probes, we ended up getting 600 and 700 feet, but really they were about 500 feet as you could really rely on that.
Yeah, and that of course all depends on building structure. If you've got a commercial job and you've got a mezzanine tend to really mess with things. And, machinery that is in a commercial building. I did a job over at Pepsi, and they've got a bottler over there. And I mean, just the machines and all the frequencies going in that place, you just need a capper, the bottler, the fillers. I mean, everything that you go through there. It was amazing we got any signal at all. And actually, it was surprisingly good. We got a lot of great signal and we got a lot of range out of it. So it worked out well. Anybody have any other questions that we didn't get to that we can on here? I think we're about out of time.
Yeah, we've got, what do we got? I think we're about out of time. I thought, what were we going to go to, quarter of or just on the half hour?
We can, and I can actually go into something else on here on our on the screen here.
Well, Eric, just before we do, you just might want to say the long range probe and the short range probe. Do you need anything as far as when you put them together? Should you go ahead and, meaning if you have long range and short range, is there anything special you need to do to get it hooked up?
No, they're just another probe to be paired into the system. The thing is, with the long range probes, if you have a standard range system and you have an iConnect per se, now the combination of probes that you can use is to get a 911M, which is the temperature humidity probe. You can get that in the long range, and a repeater. So inside, you're going to substitute one of your supply return probes with the new long range, and then have the repeater for the outdoor use. That way you'll have a long range probe on the inside of the structure and one on the outside. That will give you long range capability. So it's not just a point of buying two of the 912Ms. I understand a lot of these guys, they bought a 911M because then they can use that other 911M on the outside to get their outdoor air temperature, their ambient air temperature with wet bulb or relative humidity outside as well. So that's a good way to do it.
So Norm mentioned repeater placement for a package unit on the roof and taking readings from the first floor. Do the repeaters need to be in line of sight?
There needs to be an outlet for the signal. Shooting through concrete, depending upon the structure of the roof. If it's a multi-story unit, you could have fibered concrete, with floor joists that, there's lightweight concrete on them with, there could be rebar. Don't know. Depends on the structure. But for the best practice is to get it, the signal to basically come outside, go through windows, or, I've even used elevator shafts to transmit a signal.
Cool. David Small's got a question. Can I connect a line temperature probe to my air temperature probe, use it in the attic to get the LLT in the attic to compare the LLT at the condenser? How do I map it? Got both clamps on a strap on the line temp probes, two of each.
Now, if you want to take your liquid line temperature at the coil, say it is in an attic, you can use the 912M, which is the repeater with temperature. That probe will allow you to go ahead and plug into it. I've got a probe right here. This is a pressure probe. So basically, you're not going to have the head on here. And here's your temperatures here. So if we were to take this, actually, I can show you live. Hold on one second. So if you look on the screen, we look at active temps. And let's go to a probe here. I'm going to add in this other probe right quick. Add this in another system here. Hold on. One sec. Now this is a high pressure probe. Now we don't have to map this to anything because we don't have any, looking for another probe that I might have to plug into this thing. If we were to take this probe right here on high pressure and we see this LLT, this could be on a 912M probe, and plugging that temperature probe in here and mapping this to the liquid line temperature, and that would take it off of this high pressure, because you would unmap that, you would get rid of that. And how you would do that is swap it. That way that T1 there, it's not mapped up to anything. This is just a temperature that this high pressure probe that's actually hooked up on the condenser, it's just reading a temperature. It's not mapping in LLT right now. And this one, I could plug in a thermistor here and take LLT at this point. So it's fully configurable.
Cool. Great. Bill Hansen, you got a good question about whether you can expose the iManifold to high refrigerant heat, 180 degrees, or should he just go with his manual? I would say you better try it out. Let's make that work, because 180 degrees, Nick, what do you think? Should it be able to handle 180?
I'm not sure what the actual rating of that would be, but that shouldn't hurt anything.
Yeah, you ought to be able to use it, right? Eric, what do you think?
As far as the refrigerant temperature being 180 degrees?
Well, he just wanted to know, should he avoid exposing the iManifold to high refrigerant heat levels for an extended period of time, or can the unit handle these higher temperatures? Because he's working on stuff, right? And that's what he was using it for. So
180 degrees, when you really think about it, out here in Phoenix, if you got any reflective stuff, it's not a lot. You can put a thermometer in an attic, and I mean, it's not uncommon to have 150 degrees in an attic.
Yeah.
So I mean, we use probes up in attics. It's really going to be the limitations of the batteries, because when batteries get super hot, they cut out too. They just quit working, just like when they get super cold.
Yeah.
But I mean, as far as the refrigerant temperature, I don't think that's going to have any effect on the manifold, or it's going to have any effect on that on the probes themselves, because it is a ceramic pressure transducer. I don't think they're really going to have an adverse effect on that with that much heat. That's not really a whole lot of heat.
It shouldn't, but let's learn from it, Bill. Run it, and we'll support it if we're all going to learn it doesn't work.
Okay, Nick, start a fire, boil some refrigerant. Hook it up to something that's pumping a bunch of steam, and we'll find out.
All right.
And that's another thing, just like with our pressure transducers, those can be used to measure oil pressure on semi-hermetic compressors as well.
Cool.
Just another little thing that we've got there. That's
all right. Well, it's Friday. I think everybody on this end's probably ready to go do something different.
absolutely. I still got work to do.
You still got to keep working, Eric, a little bit. But you're up at all hours of the time, man. Everybody talking to everybody, helping everybody. So Eric's your guy for that. He's unbelievable. So
We got a lot of questions.
Next right there.
Yeah, and again, any other questions that you guys have, post that on Tech Talk, and we'll get to it when we can. Like Eric said, even right after this, if you guys want to start posting stuff on there now, then we'll get to that, and then everybody can see that on our Tech Talk. So that'd be a good way to go about it.
Cool.
And if there's anything that you want us to go over, another training, something that you're not clear about, some more information that you want, post that on Tech Talk as well.
All right, everybody.
Thanks, everybody, for
Thank
your
you so much.
Coming. See ya.
We'll talk again soon.
Thanks, guys. Goodbye.